Hi dear children, welcome to our digital lesson. Today our teaching topic is similar triangles part 1 of class 10. Similarity of triangles means the corresponding angles of the two triangles are equal and their corresponding sides are proportional. Then we can say that the given two triangles are similar. First of all, we have to remember this point very well. Next, we will get into our topic. So, objectives of today's class are understand the concept of the similarity, understanding the basic proportionality theorem. BPT means basic proportionality theorem and its applications. Symbolic representations. My dear children, let us recap some symbols which we use in our topic. Symbolic representation, ratio. This is the symbol for ratio, and then similar is the symbol for similar, and triangle, this is triangle, and proportion is double ratio, that is A is to B is equals to C is to, that is equals to, that is A by B is equals to C by D. Some more terms used in this topic are equiangular triangles. See, the triangle ABC and the triangle DEF are given as 60 degrees, 40, 80, 60, 40, 80. Compare the corresponding angles of the both triangles. Yes, the corresponding angles of this triangle and this triangle are equal. Therefore, we can say that they are similar. See, this is the triangle ABC and another triangle is DEF. What is the corresponding side of this ABC? This is 6 centimeters and this is side is DE is 3 centimeters. This side is 4 centimeters and this side is corresponding side is 2. 4 by 2 is again 2 and side AC by side DF is also equals to 2. Therefore, we say them that the proportional triangles. See, my dear children, on the screen, AB by DE is equals to BC by EF is equals to AC by DF, that is 6 by 3 and 4 by 2 and 8 by 4 all are equal, that is 2. Therefore, they are said to be proportional triangles. Angle A equals to angle D, angle B equals to angle E, angle C is equals to angle F. Next, AB by DE is equals to BC by EF is equals to AC by DF. Most certainly, we should write these two steps as soon we get or given the two triangles are similar. Now, introduction, my dear children. Now, we are getting into the topic similar triangles. A topic or in your chapter, it was started with an introduction with an example. Snigdha is a girl, she wants to find the height of the tall tree which is in the backyard of her home, but she could not do, and meanwhile her uncle came to her house, and then she took the help of her uncle, and uncle meanwhile just thought of an idea, and he asked Snigdha to bring a mirror, and he adjusted the mirror in the courtyard on the floor, so as the Snigdha could view or see the top of the tree in the image of the mirror, and he drew these two triangles, and simply he find the height of the triangle without actually finding it. This is a tower, and these are the high rise buildings, and we can without actually finding these heights we can find by using similarity of triangles. You can find the heights of the high rise buildings without actually measuring it. Again, observe one more figure. Yes, similar squares. Why they are similar? Just now I told you that the similarity only lies in two factors. What are they? If they are equiangular or their sides are proportional, ultimately they will be similar to each other. Here this angle and this angle are all right angles, are that is 90 degrees, and this angles in this square also equal, in this square also equal. Therefore, we can say them that they are similar squares. Likewise, you see similar triangles, similar equilateral triangles, because all the angles in these two triangles are 60, 60, 60. Their corresponding angles are also equal. Therefore, we can say that they are equiangular and therefore, they are similar to each other. In this circles also one point, let us assume this point, the angles around the point is 360 degrees in every circle. Therefore, they are also called as similar triangles. See now, they are equiangular, so they are similar. Now, my dear children, Rama is an active teacher. Her student performed an activity using square lamina. Here you see, my dear children, a square lamina she took, and under the light she hold it here like this. And what happens if we keep anything, any hard substances in the path of light? Most certainly will get shadow. And what they did, you know, this is the ratio of, see, AB is 10 and A dash B dash is 20, AB by A dash B dash, and again next corresponding side is AB A D and A dash D dash, and again similarly CD by C dash D dash and BC by B dash C dash. What they find? Yes, most certainly they are equal, therefore, they are similar. And now I am going to start the chapter. Before starting this chapter, you have to remember, my dear children, first R stands for representation and second R stands for redraw. Most of the pupil, 4 out of the 5 children feel similar triangles tough. If you understand this concept representation properly, it becomes as easy as sets. See now, let me explain what is representation mean. A, B, C, D, E, F. It is not D, E, F, D, F, E. And then the question 5, 6, 4. The sides of the first triangle A, B, C are 5, 6, 4 and second triangle D, F, E is 15, 18, 12. Most certainly more number of the children, I just asked them whether the triangle ABC is similar to DEF. Most of the children answered me yes, they are. Illusionary defect will be seen. My dear children, see 5, 6, 4 and 15, 18, 12 is okay. As per the lengths are concerned, they are looking like similar, but is it similar? Is ABC is similar to DEF. AB by DE is equals to BC by EF is equals to AC by DF. I said at the beginning, to check the similarity of triangles, what we have to do? Either equiangular or their corresponding sides should be proportional. Let us observe, because he asked us to find is ABC is similar to DEF? No. To check this, AB, this is the corresponding side of this AB is DF. Is AB by this is DE, here whatever the given is DEF, no, AB by DE is equals to BC by EF, AB by DE is equals to BC by DF, EF and AC by DF. This is 5 by 12 is equals to 6 by 18 is equals to 4 by 15. Is it proportional? No, it is wrong. They are not similar. Then how can we represent properly? Is ABC is now similar? No, they are not similar to each other, because they are not in proportional. Therefore, they are not similar. So, let me check, but AB by DF, this is AB, this corresponding side is DF, AB by DF, AB by DF and again BC by FE, BC by FE, and this is third side, this the corresponding third side is this. This third side AC by DE is equals to what? 3. Therefore, triangle ABC is similar to DFE. Previous example, I took an example with proportional sides, and in next example I took to show the representation of the similarity, I took the angles as the parameter. And then now we are going to discuss a very important theorem, that is basic proportionality theorem. It plays a vital role in finding heights and more problems can be solved. Let us observe the basic proportionality theorem. See what the theorem says. If a line is drawn parallel to one side of the triangle to intersect the other two sides in the distinct points, it divides the other two sides in the same ratio. See what is the first line? If a line is drawn parallel to one side of the triangle, let me take a triangle first here, and I am drawing a line parallel to the given triangle ABC, and second line, it intersects the other two sides in distinct points. This is one point and this is another point. Let me name them as D and E. Now, the condition is fulfilled and this is AD, this is DB, this is AE, this is EC. Then what we have to show? Last line, it divides the other two sides in the same ratio. How can we represent the ratio of the other two sides or fragments? See, AD by DB is equals to AE by EC. Now, let me prove it. See, this is a triangle, another parallel line cut in two distinct points in two points D and E, and then what happened? So, there the line divided entire triangle in two regions, one is ADE triangle and another is DECB trapezium. How can I show the lengths are proportional? No, if two triangles are there, I can compare, but one triangle and one trapezium is there. So, just I am taking a construction in this figure, I am joining DC and joining EB, so that two triangles are formed. See how they formed. DEB a triangle is formed and DEC another triangle is formed. Now, see my dear children, this is the triangle ADE. I am dragging one more triangle from the same place. Are they equal? Most certainly. Why? Because area of ADE is equals to area of ADE. Similarly, that is reflexive property. One thing is same to itself. Next one, this triangle I am dragging outside and another triangle I am taking out, and both triangles are equal. Why? Let me show. These two triangles, red color triangle and yellow color triangles, are same or not? Yes, they are same. Why? Area of triangle DEB is equals to area of triangle DEC are equal. Why? Because they lie on the same base DE and between the same parallel lines DE and BC. Okay. Next, I have to rotate this triangle because I have to show AD by DB is equals to E by EC. No, that is the reason I am taking, I am rotating this triangle in this way. I am taking these two bases. See, AD as base of ADE and DEB, the base is DB, because I need these two sides, because I have to compare these two sides, AD by DB. To compare, I just rotated this triangle and I took the two bases as AD and DB. What happens? This is the height of the triangle, since it is a perpendicular line. This is an exterior angle triangle, the height lies outside, this is also the height of this triangle. And if I just bring back them, both became equal, the height of ADE and the height of DEC are equal in these two figures. One more time, I am taking both triangle sides are same, since EF is perpendicular to both. Now, I need this side base, because I have to show AE by EC, no? Then I will rotate this triangle this side. See, as AE base and EC base, I got these two bases AE and EC. Then what can I do? See, this is the perpendicular line. I draw this height to this triangle AED, and this is also an exterior angle triangle. The height lies outside, and this is a line drawn parallel perpendicular to this triangle. See, if I just bring together, their heights are coincided. Here in this also, both triangle sides are same DG. perpendicular to both the triangles. See now, I am comparing both of them. See area of triangle AD by area of triangle DEB, area of triangle ADE by area of triangle DEC. We have shown these two are reflexive property, they are equal. Numerators of these two fractions are equal, denominator also equal. How and why? Because they lie on the same base and between same parallel lines just we saw. Therefore, these two fractions are equal, and let me write the values of those two triangles. Now, this is the area of AD. How can I find area of AD? Half what is the base AD into what is the height EF by what is the area of this EF into base into height. Half into base is dB and height is EF, and here in this case half AE as the base I took and height is dg by this height and base EC into dg. Therefore, I wrote the formula of areas of all the triangles, and now half and half will be gets cancelled and this will be gets cancelled EF because both are equal, and what is remain AD by dB is equals to AE by EC. Hence, the theorem is proved. Now, my dear children, we are going to discuss some problems which are on applications of basic proportionality theorem. Imagine, till now we understood how to represent the similar triangles in a proper way. Now, imagine as you redraw the given triangles, and then it is very easy to you to understand and to solve the problems. Let me explain one problem. See, this is in the figure, DE is parallel to AC and DF is parallel to AE. See, given DE is parallel to AC, DE is parallel to AC and DE is parallel to AC and DF is parallel to AE. Prove that BF by EFE is equals to BE by EC. How can we prove? So, just consider ABE triangle in which DF is parallel to AE is given. Let me draw this and imagine it was taken out and this is rotated. It is very easy to us to understand or to do the problem, because it is given DF is parallel to AE. Immediately, what is the theorem we have discussed? The basic proportional theorem. If a line parallel to one side of the triangle, the other two sides ratio will be equal. Therefore, how can I write this? BE by EFE is equals to BD by DA by using basic proportionality theorem. This is an equation 1, let us assume. Next, one more triangle, consider ABC. In this, two triangles are there. See the small triangle and big triangle ABC. Imagine it was also drawn out and imagine it was rotated as it, and then you understand, yes, it is given that DE is parallel to given DE is parallel to AC. Immediately what can we write? The ratio of their sides are proportional. See, by using basic proportionality theorem, BE by EC is equals to BD by DA. This is equation 2. Compare both the equation, here BD by DA and BD by DA. See, by using transitive property, BD by DA is equals to BF by FE, BD by DA is equals to BE by EC. By using transitive property, the left hand sides of those two equations are also equal. Hence, proved. One more problem, let me explain this. ABCD is a trapezium in which AB is parallel to DC and its diagonal intersects each other at O. Show that AO divided by BO is equals to CO by DO. Now, very simple, if you draw a line in trapezium ABCD, draw a line PQ parallel to DC as well as AB, then what happens? This, consider this triangle now. What is the to be considered? ADC. Now, in triangle ADC, PQ is parallel to DC, and using basic proportionality theorem, what can we write? DP by PA. See here, DP by PA, OC by OA. Now, I am writing the same. DP by PA is equals to CO by AO. This is first equation. Consider again the same another triangle ADB, then this is parallel to this. What it is parallel? PQ is parallel to this AB also. Therefore, in this triangle, see, we can apply basic proportionality theorem. This is parallel to this, hence dP by PA is equals to dO by OB we can write. I am writing the same. In triangle ADB, PQ is parallel to AB, and using basic proportionality theorem, dP by PA is equals to dO by OB. This is second equation. Compare both of them. Comparing equation 1 and 2, dP by PA is equals to dP by PA. So, here I can take the right hand sides of both equations, CO by OA or AO is equals to dO by OB, but he did not ask us to show this. See, we have to show AO by BO is equals to CO by DO. Hence, what I have to do, simply I am rearranging the terms to represent the answer in the given form. What I am doing, see, by cross multiplying and taking the rest of the problem solution to this place. Cross multiplying, what happens here, CO is numerator and OB is denominator, will be get multiplied, CO by into BO is equals to, this is denominator, this is numerator, OA into DO, and rearrange the terms into our required form. See here like this, rearranging the terms above, we get AO by, see, this is AO I am keeping as it is, and taking BO, this is multiplication symbol. If I transpose this BO to that, it becomes by AO by BO, and CO I am keeping as it is in this side CO, and this DO, this is multiplication symbol is there. Therefore, bring DO to this denominator, it becomes, hence this is the required condition form to show us, hence it is proved. Now, one more important thing we have to observe in the same application of basic proportionality theorem, we can divide, actually measuring, we can divide the given line segment into the given ratio. How? See, draw a line segment of length 7.2 centimeters and divide it in the ratio of 5:3. Measure the two parts and verify the results also. Then I am assuming this ratio as m is to n. Therefore, m is to n is 5:3, and m plus the sum of all the ratios is 8. Therefore, it is to be taken as 8. Let me explain the process on the slide, and then we will see the practically how to be drawn in a video. See, let me explain. See, draw a line segment AB of length 7.2 centimeters, and this is a line AB of 7.2 centimeters. Draw an angle ray AX making acute angle with AB in such a way, AX, and what we have to do? We have to divide it into 8 divisions. Draw 8 equal arcs on AX and name them as A1, A2, A3, A4, A5, A6, A7, A8 likewise, and then join A8 to B, and then which is the required ratio? 5:3. Therefore, we have to take a point at 5 and draw parallel to 8 A8B to A5 to the given line. And how it is to be done? That parallel line most certainly divides in the given ratio. How it is to be, now this. See, my dear children, how the line segment is to be divided in the ratio 5:3 practically. Take a line segment 7.2 centimeters AB, line segment 7.2 centimeters, and then draw an acute angle ray. See, now draw an acute angle ray AX underneath of that line segment AB, AX, then it is to be divided into 8 equal parts. How can we do? We can divide this equal into 8 equal parts with the help of compass. Take compass, adjust. If I take that much, I can't draw 8 equal parts. So, I am just minimizing to a smaller length. Yes, now it is easily I can draw 8 arcs, 1, second arc, and this is the third arc, Still 8 arcs we have to draw with the help of same compass without changing its radius. Now, keep your compass aside, name them as A1, A2, A3 etcetera A8. And the last point is to be added with the end line of segment AB, B. A8 to B, draw a line from B to A8, and now you have to draw a parallel line from point phi. 5:3 is the given required ratio. No? Take fifth point, this is fifth point, draw a parallel line from point phi A5 to A8B. How? Observe carefully, we can do in a multiple ways. See, we can use by using protractor also we can do. We can draw a parallel line, or by using compass, or by using protractor, and as by using set square also we can draw, but it is a very easiest way to draw a parallel line by using a compass. Just find the measure the arc length, radius we have drawn equal arc to its radius, and now length of the arc just you cut here, and this is the intersecting point. From A5 to this you draw a line from point A5 to AB, which intersects AB in the ratio 5:3. Because it is parallel to this, the line, the side is 5:3 ratio. So, most certainly the above A, this fragments also will be in the ratio 5:3 by using basic proportionality theorem. Thank you, my dear children. Let us meet in the next session.